Right, this is Chapter 8, Summary Notes on the Gas Laws. This one is on Avogadro's Law. All right, Avogadro's Law obviously involves moles, because we've seen Avogadro's number before at 6.02 times 10 to the 23rd. All right, so we know we're going to be dealing with moles, and that's in the ideal gas law equation right here. And on the left side of the expression, we have the volume. So volume is going to vary directly with the moles when we set one set of conditions equal to another. Okay, and you can see the working formula here on the left of your screen. And we will need to clear terms depending on what we're asked to find. All right, but also please know that we have the pressure and the temperature will be kept constant, and we keep referring to the R value also is of the gas law constant. All right, so let's set up this next problem and assign terms. And we'll start with the moles because it says of 0.75 moles of helium. So that's our N1. And we can scoot along and read. We have a second volume. I'm going to go ahead and take care of my other mole quantity, which is 1.2 moles of helium. So that's how that condition changes. The volume, all right, the first given volume is 1.5 liters. And we're looking for the second volume. All right, so again, we can predict, since this is a direct relationship, if volume goes up, then moles also need to go up because there's more room for more particles. Okay, so in this case, we're looking for volume. Moles are going up, so the volume should also increase. All right, so when we rearrange this formula, all right, we're solving for V2. So the N2 term can be cleared by multiplying both sides by N2 over 1 and bringing it to the numerator position on the left of the expression. All right, so I'm going to rewrite that down here. 1.20 moles of helium is my N2 over N1, which is 0.75. And then we're multiplying by the volume, which is 1.5 liters. And this is equaling V2. Over here on my trusty calculator, 1.2 divided by 0.75. And then times 1.5. And I get 2.4 liters. All right, so 2.4 liters. So does it go up? Yes, it does. All right, it goes from 1.5 to 2.4. This is much like the way we did Charles' law and Gay-Lussac's law. Both of those were also direct relationships, as is Avogadro's law. All right, now let's try something a little different. All right, here's the question. It says, what volume occupied by 2.7 moles of N2 gas? What is the volume occupied by 275 moles of N2 gas? All right, well, one thing you need to know is that 1 mole of any gas at STP is equal to 22.4 liters. Okay, STP is standard temperature and pressure. That's 1 atmosphere and 0 degrees Celsius, or 273 Kelvin. But that's how much any gas will occupy this quantity of liters. So notice we have an equality here that we can use to help solve problems if you have STP conditions, which is what we're going to see in these next few problems. All right, so in this first problem, right, this is a variation on a theme. We don't need that V1 over N1 equals V2 over N2 for these because these are a little different. All right, and if you recognize what you're asked to do, you'll be able to solve very quickly your answer. All right, so we have 275 moles of N2. We are at STP, so we can use this relationship, that factor, I'll do that in a different color, with 1 mole on the bottom and 22.4 liters on top. Okay? All right, so we can just multiply across times 22.4, and I get 61.6 liters. All right, so at STP, this moles of gas, 2.75, will occupy 61.6 liters of volume. Okay? All right, now you try this one. This one maybe will give you a little bit of help on this one. It's starting with grams. What do you need to do if we need grams, but our problem is dealing with moles? Is your head swiveling to the periodic table? I hope so. All right, so we need molar mass. All right, because if we got to change grams to mole, we need molar mass first. All right, so let's do a first molar mass. Okay, first molar mass, change grams to moles, and then change moles to liters. Okay? All right, so let's write our given down, 4.00 grams of CH4. All right, and CH4 is 12.01 plus 4 times 1.008, and that gives me 16.01, trust me. Okay, grams per mole. Remember, I've always urged you to write grams per mole there so you can see it as a factor. All right, so let's bring that in as a factor and we'll find moles. All right, so I have grams that can cancel. All right, so this will give me, if I do this little division, that will give me moles. All right, and then notice I need to go from moles to liters at STP. So moles to liters at STP. All right, I know I need my volume, and the 1 mole part goes on the bottom. Okay, and that will get me liters at STP. So I have 4 divided by 1601 times 22.4. All right, and that gets me 5.596 liters. And do you see that up here? Yes, you see that as the first answer, 5.60, when we round to 3 significant digits. All right. All right, so you try this next one. I'll leave that up so you can see how it works. Pause the video and then come back and check your answer. Okay, did you catch what you needed to do differently? We're starting with liters in this case. So if you're starting with liters, did you use the equality that involves the 1 mole over 22.4 liters to get your moles first? And then change moles back to grams? All right, so let's take a look at how that happened. All right, we were starting with 8 liters. All right, so if I know that we're at STP, I can use this factor, the 1 mole over 22.4 liters, to get back moles of this gas. And then I know the gram quantity of helium at 1 mole is 4.003. All right, so I bring that in as a multiplier, and I get 1.429, rounded to 3 significant digits of 1.43 grams. All right, so those are some variations for Avogadro's law. Let me just back up a moment. All right, Avogadro's law is volume and number of moles. And sometimes some of the problems will, when you work from the first set of conditions to the second set of conditions, they will add moles to what you have originally. They don't actually give you an N2 value. All right, they might say you started with 1 mole, they've added 2 more moles to this, so you have a total of 3. So watch out for that variation in the problems. All right, the other variation that we saw was that 1 mole of any gas occupies 22.4 liters. We can use that as a factor to go from moles to liters or liters back to moles. And of course, if we have moles, we can bring grams in, either solving for grams given a volume or going to volume given grams. All right, and that's Avogadro's law.